today I'll be running you through some of the issues we encountered when deploying our data platform with Terraform, what we learned from it, and what you can do to avoid similar issues. So this is going to be a quick run through of the top 10 issues we've had. It's not going to be exhaustive. We're not going to go into demos. There's no Q&A, so if you want to ask questions, come see me downstairs at the end. So just to start off, who am I? I'm Ben Roberts. I'm a data engineering consultant with Advancing Analytics. I've done quite a bit with Terraform, mainly around data platform deployments. So starting off with existing infrastructure irritation. So as data platform developers, or as someone deploying a data platform with Terraform, it's possible that the environment you're deploying into has an existing sort of Terraform configuration in use. That might be a centralized infrastructure team deploying, the corporate sort of corporate hub, or it might be some security team deploying policies, or some other kind of like existing uses of Terraform. So the first thing to sort of keep in mind is, if these other configurations exist, how are you going to integrate your deployment with them? And what you might have is something like this. So on the left, you've got your infrastructure team deploying things like policies, management groups, virtual networks, VNet gateways, all of the sort of the core infrastructure stuff that they're going to look after. And then you, as the data team, you might have your own little configuration, right, concerned with primarily data infrastructure. So networking, a little bit of it, Databricks, SQLDB, Key Vault, Synapse, storage accounts, all of your sort of data infrastructure. So when you've got this kind of like two configuration setup, where one of them is responsible for something else, there's a few things you've got to keep in mind. First off, it's tempting to try to use Terraform's remote state functionality to interact between the child configuration, the smaller one, and the parent. That's not going to work because it means that you're exposing absolutely everything in that parent configuration to the child, even things that aren't going to be relevant. Their Terraform configuration may also differ from yours. So where their Terraform configuration is going to try and keep the infrastructure that's been deployed consistent with them, if that's different to your definition that you're deploying, you'll find yourself in a game of cat and mouse. You change something, and then when they deploy, they change it back from what you changed it to, and you go round and round and round, which isn't great. And then on top of that, is there a robust process in place to make sure that the changes they're making aren't going to fundamentally break your platform? It's annoying when it's a relatively minor thing being renamed. It's absolutely disastrous if it's going to involve your configuration breaking completely. And on top of that, the people managing that central deployment, they're going to have their own people reviewing their Terraform plans. Does this make sense? Is this right? But are they going to be able to do that for yours? Are they going to be able to look at their plan and say, not just does this work for us, but is this going to have downstream impacts on you? And combined with that, your deployment cadence is likely to be different. If you're doing a data platform deployment and you're deploying every week, trying to get infrastructure spun up and working, and then you've got another Terraform configuration that runs every 6 months, are you setting yourself up for 6 months down the line some serious pain when everything breaks? So once you've taken that into account, you're then going to need to work out what permissions you need to do your deployment. Moving on to pernicious permissions. I'm not going to try and get that right. So if I want to deploy the following in Terraform, what permission on the subscription do I need? So if I want to create a resource group, create an ADLS, and then grant access to that ADLS with an Azure RBAC role assignment, on the subscription, I'm going to need owner-level access. Because having owner on the subscription means that when I create the resource group, I have owner on that as well, and then I can do the role assignment on any resources inside it. But if you've got owner over a subscription, you've got owner over everything in that subscription. So if you've got your sort of data platform sitting in a resource group, you're going to have control over all the resource groups that aren't your data platform as well, which obviously carries risk. But if you change the situation slightly, so if you're creating an ADLS in an existing resource group that Terraform already has an Azure RBAC assignment on for owner, and you want to grant access, what do you need on the subscription? Nothing. Absolutely nothing. You can remove all access to that subscription. So if you slightly change what you're trying to do, so changing from creating resource groups in Terraform to creating them somewhere else and then using them in Terraform, you can drastically reduce the permissions that your Terraform service principal needs, and therefore reduce the risk if those credentials get misused. So yeah, ask Terraform to do slightly less. Align the permissions you give Terraform to the scope of your project. If you're deploying a data platform, it doesn't need any more permissions over anything that's not a data platform. And indeed, can you actually separate out into separate Terraform configurations? If you've got one that's creating resource groups and assigning RBAC roles, and you've got one that's deploying your data platform, they don't need to be in the same Terraform configuration. It might be safer to break them out, because then you have one Terraform configuration that doesn't change very much and is only ever sort of interacted with by people who are trusted. And then you've got another Terraform configuration that uses far less permissions. The service principal can have far less roles assigned to it, and therefore it's less risky if someone does something questionable. And the question is all about risk. What is the risk of this service principal being used incorrectly? OK, moving on to our next point. So we've got permissions, we've got everything, but there's something we've forgotten. Azure AD agony. So the Azure RM provider for Terraform, you think it just handles Azure infrastructure. It doesn't. It also has an underlying use of Azure AD in some cases. So you need to watch out for where your Terraform configuration might have a hidden Azure AD dependency. So for example, here you can see I've put together a role assignment with a GUID that doesn't look quite right. That's probably not a real GUID. But because Terraform, the service principal I'm using here, doesn't have Azure AD access, it just sits there forever. And so even though I'm just working with Azure resources and I don't have anything in there that specifically says RBAC, I've still got an Azure AD dependency. So anything that involves translating friendly user names, group names, service principal names into their object ID values is going to need Azure AD somewhere. And you can try to skip that. So with the previous example, I can say skip checking it, and it'll work. But then I end up with this. I end up with hard-coded GUIDs everywhere in my Terraform configuration. And whilst that's machine readable, to me, as a Terraform developer, that's absolutely useless. I'm going to have a variables file full of GUIDs, and it's going to tell me absolutely nothing about what group is actually being given access. I'm going to have to go and paste that into the Azure portal. So Azure AD agony, the solution is to rely on Azure AD. Use it explicitly. Don't just use the hidden Azure RM dependencies. So try doing something like this. So at the top, we build up the Azure group name by formula. We join our app name with the environment with the name admin. Then we look it up in Azure AD to get the admin group ID, and then we can use that ID in a role assignment. And so rather than having hard-coded GUIDs everywhere, I've now got the name of the group being built in a formula, so I don't even have to change the group name when I move between environments. As long as that environment variable has been updated, I'm now going to be pulling back a different group. And so it's far more slick, and there's less for me to change when I move between environments. So all our permissions are in place, Azure AD access is sorted, and we're now going to answer the question, where am I going to store the state file? So, state store snafu. So, because we're all wanting to be as secure as possible, and we're using Azure, we want to say, I'm going to store my state file in an Azure storage account and authenticate with Azure AD. I'm not going to have access keys anywhere. I'm going to do it all with Azure AD authentication, because that's the best way to do it, and it's the most secure way to do it. And so what you think is going to happen is something like this. Terraform goes to Azure AD, authenticates, and then it uses its authentication token to go to the storage account, and it gets its state file out. Brilliant, you think. Except that that's not what Terraform actually does. What Terraform does is this. It says to Azure AD, I want to authenticate, and Azure AD says, yep, sure. Then it says to the storage account, give me the master access key. And it gets that back, and then it gets its file using the access key. Now, why does this matter? The reason it matters is because of this quote. Your storage account access keys are similar to a root password for your storage account. And then below, when we get into ACLs, ACLs do not apply when that storage account access key is in use. So if you were thinking, I'm going to have one storage account, and then I'm going to have a dev container, a test container, and a prod container, I'm going to put my state file into each container and then use ACLs to restrict it, that's not going to work. Because your developer credential that you're using with Terraform, because it's going to be able to get that access key out, is just going to be able to grab the access key for prod and then read out all of your nice prod secrets. And if your security model is that developers have access to dev but not to prod, that's just going to poke a hole in it. So the solution, the only one I could find, was to just use separate storage accounts per configurations. Because it's getting the access key, the only sort of scoping you've got is by storage account. And having sort of looked through the Terraform code base, that's how it works. There's no little flag you can enable Azure AD authentication properly on. It's just going to get the access key. So storage account scope is how you're going to have to do it. So you've now got your state file stored securely. You've got all your permissions. You're now going to choose how to lay out your project, which brings us on to tenuous testing. So normal code, when you deploy it, your process looks something like this. You take some code, you stick it in dev, and if it works, you go to test, and if it's still working, you go to prod. It's the same code being moved between environments. We use tools like Git or TFS and Azure DevOps pipelines to ensure that the code we put in dev is the same as in test. You know, we work with branches and we do PRs to make sure that, you know, the code that we're deploying, we're not going to have sudden mutations in the middle. We're not going to have something in dev suddenly mutate on its way into test. You know, that's all restricted and that's quite carefully managed. But there are some online guides that encourage the use of a folder per environment. So within your Terraform project, you've got this modules directory where you stick all your modules, and then a folder for dev, a folder for test, and a folder called prod. And then you deploy your dev folder into dev, and your test folder into test, and your prod folder into prod. The problem with this is that your deployment method is to if something works in dev, you copy and paste the Terraform into the test folder, and then if it works, you copy and paste it into prod. But that just seems a bit suspicious to me. I mean, maybe it makes sense for deploying infrastructure. And that's where I think, the actual use case for this approach is. But if you're sort of just deploying a relatively small data platform, what this means is that your sort of final production code isn't actually tested until it gets to production. How do you know that that copy and pasting has been done right? And unless you're going to have a dev and a test dev and a prod dev and a dev prod and a test, right, down that road madness lies, and it's not a very long road, okay? So, again, just going through the problems, changes to the modules also will take effect immediately. Anything that's in an environment folder needs to be copy-pasted, and you're not testing until you get to your production form. You're not testing production code until it hits production. So the way sort of I solved this was you can feed different environment files per environment rather than feeding whole Terraform configurations. And you can also use these little flags, using this little operator here at the top of the screenshot to enable or disable modules per environment. So if you're saying, I want to try Synapse in dev and I never want it to progress through to test or prod, you can use that little count cheat there to do it. It's not generally great to have loads of conditionals in a Terraform configuration. It's discouraged. But I would suggest that a couple of hacks like that is better than your deployment process involving copy and paste. So now that you've chosen how to lay out your project, now you need to get some infrastructure built. And for that, you need providers. But then you get provider problems. So Terraform providers, what do I need to create and configure a Databricks workspace? I'm going to need the Azure RM provider to create the workspace, and I'm going to need the Databricks provider to do the configuration, or anything else that's going to involve a second provider coming in and doing configuration after an initial resource has been created. I've chosen Databricks here because it's the example I'm most familiar with. But we end up in a bit of a catch-22 with this. So the Databricks provider, or the client provider here, needs the workspace info to instantiate. But the providers instantiate when Terraform starts running. And the Databricks workspace details aren't going to be available until the Azure RM provider has created it. And if you try and stuff it into its own little module, then you can't use the depends on logic, so you can't do something like create a workspace, create a cluster, and then stuff the cluster ID into Key Vault. That's not going to work. So where you've got that kind of infrastructure create and then infrastructure being configured by a separate provider, what we've ended up doing is multi-phase Terraform deployments. So we'll only invoke that Databricks provider and the Terraform configuration that contains that provider once we're certain that we've got all the information we need for it to run. So, at the top there on the left, we've got phase 1 infrastructure. That's going to get our Databricks workspace together. We actually only start configuring it in phase 3 at the end. And that means that we're damn sure that we've got a Databricks workspace before we try and tell the provider to get ready to go. We also have that allows us to accommodate manual activities. So if you've got something that has to be done by hand, if you've got permissions that can't be automated because it's got to be a specific person in a company doing it, or if you've got DNS requests or firewall requests to be raised, breaking it down into multiple phases can help you because you can't get Terraform to wait in the middle of a single configuration. And then we use remote state to pass between phases. So if we've created a key vault and we need to pass the ID of that key vault down the chain, then you can use Terraform remote state to pull it out. Remote state allows you to access a different state file in a configuration. So we've got the providers sorted. Now we're going to write some modules. But how do we structure them? And that brings us on to module malarkey. So I was really torturing the alliteration by this point. So we've got an example Terraform project here. Top level on the left, you've got a project folder. And then you've got some modules, right? You've got Key Vault module, storage account module, virtual networks, yeah. So if you wanted to, for example, stick a storage account access key or any other sort of value into a Key Vault secret, where would you do that? So you could say, well, the Key Vault module deals with Key Vault, so I'm going to tell Key Vault module to store the access key. Or you could say, well, the access key is generated in the storage account module, so that's where I'm going to have the secret be created. On here, that's option 1 and option 2. But the problem is that then your Key Vault module is going to be expecting some kind of storage account parameter, or your storage account module is going to be expecting some kind of Key Vault parameter. And the problem with that is that if you want to take that module and pick it up and move it somewhere else, I want to reuse that module, I've now got this tangled spaghetti mess of module dependencies, right? I can't just take this module and move it because, if I choose option 1 or option 2 here, now if I want to have Key Vault without a storage account, I've got to rewrite my Key Vault module. So what I'd suggest doing is going with option 3, create a separate module just for secrets. Or, I did this as well for Azure role assignments, because that means that my sort of modules remain nice and pure, as it were. They're not concerned with things that they're not meant to be concerned with. And it means that I've got a really nice storage account module that when I start a new Terraform project, I can just grab that module and paste it straight in, and I'm not worried about what other ancillary resources I'm trying to get at the same time. So we've got our Terraform provider Terraform configuration written, and we're ready to deploy. Our next risk is going to be data plane disasters. So imagine this, right? Your Terraform configuration, you are going to create a storage account, you're going to create a container in that storage account, and then you're also going to put the storage account access key into Key Vault. But both your storage account and your Key Vault, those are private endpoint enabled. They can't be accessed over the public internet. They can only be accessed from within the private network. And what you'll also see is that the domain name for Blob and the domain name for the Key Vault, they actually depend on what the resource is called. So some aspects of the Azure RM Terraform provider carry operations out against a resource-specific domain name. So if you've decided to go full private networking, as everyone should, is Terraform going to be able to access what it's just created? If you've got your Terraform, happily sitting there creating storage accounts, it's fine that it can create the storage account because that's against the Azure API, but is it then going to be able to do anything with that storage account? Because that's going to need, DNS, the firewall, any network security gateways, or any routes to be advertised. So just because it's able to create the resource doesn't mean it's then going to be able to do anything with it. And what will happen is that Terraform will get halfway through and then fail. It'll just fall on its face. So what can you do? Well, you could make everything managed by Terraform, right? That's not going to work in the real world for a large organization. Or you could just say, well, anything data plane related goes in its own Terraform configuration that runs once we know everything's in place. That's what we did. Or you just accept failures during deployment. You run the pipeline, it creates the infrastructure, and then it fails. Then you do all the manual stuff, and then you run it again, and it succeeds. It's all right, but it doesn't look great, and your pipeline success rate is just going to go through the floor. Moving quickly on, DevOps pipelines. Proud of this one. So you've decided to be super secure, developers have no access, and all your deployments through DevOps. The build agent gets rebooted halfway through. What happens? Well, if you restart the pipeline, it's going to fail because it can't, because the state file has been locked, and the pipeline is now inoperable. The infrastructure is half deployed. It's 4:30 on a Friday, and everyone's gone home. So what I'd do is just build a force unlock pipeline or build some procedural controls. Very quickly, awful artifacts. Don't stick artifacts of the Terraform plan in because they contain the credentials. I can go further into that one, but basically don't store the plan. And with that, I'm at time, so I'll call it an end there. And any feedback, please stick it on there. QR code will take you to it. And I've been asked to let you know as well that the raffle will be starting immediately afterwards. Thank you.